We really already started chapter 7 because we talked about circles. This chapter is on what's called conic sections, and let me just show you where that comes from. If you put two cones and you glued them together point to point, I'm not sure how that would work out so well. But if you cut a slice that was parallel to the base, you'd get a circle. If you cut a slice that was at an angle, you'd get an oval or an ellipse. If you cut a slice that was parallel here and here, you'd get a parabola. If you cut a slice perpendicular to the base, here you'd get two of these, which is a hyperbola. Those are all conics we're going to study in this chapter. These are, okay, these are the 4 things you have to know. They're all on the pink sheet. Now, these we're not going to, we've already studied point lines and intersecting lines in geometry, right? But these are called conics. They're called degenerate conics because if you cut through here, you'd get a point. If you laid your plane right along the slant height here, the slant edge, you'd get a line. If you cut perpendicular to the diameter of the base, you'd get intersecting lines. All right. That's why we call this chapter conics. Now, the conic we're studying today is a parabola, and I want to give you a funky definition. Do you remember doing parabolas earlier this year? We did this kind of a situation. Vertex form, yes? We were all good with vertex form. Last year in Algebra 2, you did some stuff where you had this. And you found the focus and the directrix. Do you very vaguely remember the words focus and directrix? Okay. All right. Okay. We're going to talk about, do you remember when I talked about the word locus of points? Locus of points for a circle. Okay, locus just means all the points that satisfy a condition. So the locus of points, if in this plane, this flat surface, this smartboard, I want all the points exactly x units away from this dot, I'm going to get a circle of radius x, yes? That's a nice radius I drew there, right? Okay. We're going to talk about a different locus of points today. Okay, here's my story time for the day. Here's a lake. It's a very tiny little lake. Here is a road. I'm going to build my house so that I drive, my driveway is exactly the same distance to the lake as it is to the road. So obviously I can put my house right here, right? And I drive the same to the lake as I would to the road. Everybody okay? But what if there's a swamp right here? I can't put my house right there. Well, I could go over here somewhere and have this distance be exactly the same as this distance, okay? I could also go over here somewhere and have this distance be the same as this distance. All of the points that satisfy that, they are said to be equidistant. That makes sense? Equidistant from this point, which is called the focus, and this line, which is called the directrix, otherwise known as the lake and the highway or whatever, okay? All the points that work equidistant from those two things would be all the points that are on this parabola. Anywhere on that parabola that I pick will be the same distance to here as it is to here. Now, when you measure to a point, you measure with a straight line. When you measure to a line, you have to make a right angle. Okay? That's the locus of points for a parabola. All points equidistant from a certain point and a line. That point is called the focus, and the line is called the directrix. Now, what you need to know conceptually is that this distance, what is this point right here, this blue dot? Look at our parabola. This is the vertex. Everybody okay with that? This distance from the focus to the vertex is going to be P. And it is exactly the same as the distance from the vertex to the directrix. All right, that's going to be called P. Now, some things you may or may not remember from last year. The focus is always inside the parabola somewhere. It is actually the focal point of, for example, a parabolic satellite dish. If you had a satellite dish that was a parabola, you would put the receiver at the focus because all of those rays, incoming things, would be focused to that spot. Okay? So it does have a purpose. That's the focus, and it's always inside the parabola. So if my parabola dish opened this way, the focus would be in here somewhere. Everybody good? The directrix is always outside on the other side of the parabola, and the parabola is bending away from the directrix. Does that make sense? Okay, it's bending away from that. All right, I think we've covered the basic concepts. So a locus is a set of all points that satisfy. The parabola is a locus of points equidistant from the focus and a line called the directrix. They're also going to talk about axis of symmetry, which we're good with already. The line that cuts it right in half, right? Goes through the vertex and the focus. All right. Now, I'm going to skip this, and I'm going to go to this one. On your notes and on your pink sheet are two formulas. Can you find it on the pink sheet? It looks like this. Here at the top, there are two formulas above parabolas. Do you see these? Find the side that has parabolas. I don't know which side I handed it out up, but okay. This is not the form we're used to seeing. I wrote underneath the form we're used to seeing for you. Is it handwritten on your sheet down there? It's underneath, but that's vertex form, yes? All this is vertex form rearranged. We used to put an A here, yes? For the stretch. A is just equal to 1 over 4p. Now what they've done is they subtracted the k to the other side and they multiplied the 4p onto the other side. So it looks like this. This is what they're going to call standard form. Now the thing is, this makes p a little bit easier to find, but sometimes they'll put it in this form and we got to multiply it around. Somehow we got to figure out what p is. What does p stand for again? The distance between the focus and the vertex, or the vertex and, okay, so back here on this slide it says p is the distance from the vertex to the focus or the vertex to the directrix. This can be rearranged to standard form, or vertex form, I mean, and it's written on your sheet underneath there. We've done that one before. When there's an x that is being squared, your parabola will open either up, if what's true. P has to be what kind of value, or A had to be what kind of value? Positive or down if we had a negative P value or a negative A value. Okay. This, where there's a y squared, not an x squared, we're going to have parabolas that open sideways. That means that we can't easily type them in our calculator to graph. They're a hot mess if we want to put them in our calculator. Okay? So we're going to be doing parabolas that open sideways. What do you think a positive p-value is going to do here? Does that make sense that if it's opening sideways, positive would be to the right and negative would be to the left? Does that seem okay with everybody? Okay, so now look on your sheet here. It says right here, p is greater than 0, it opens to the right, less than 0, it opens to the left. Does that seem good? All right. I'm going to teach this two ways today. I'm going to try to get you to just think about where the points would be using that P idea. And then I'm also just going to show you how the recipe works using these right here on the sheet. Okay, it's just a recipe. But I would like you to understand the concepts as well. All right, I'm going to do this question for you. So last one, you don't have to write anything down because it's all done on your paper. If I saw this question on my paper, the first thing I would do is I would look and I would say x is squared, so it's opening either up or down. The second thing I would probably do is right underneath it, x minus h squared equals 4p times y minus k. Because this would help me pick out right away that h is 3, that k is negative 4. Everybody all right? It's the opposite of that. And that p is, well, right here, 4p is 12, so p is 3. Then I would graph. The vertex is at 3, negative 4, because it's always hk. 1, 2, 3, 1, 2, 3, 4. Okay, there's my vertex. P is a positive. It's greater than 0, so this is going to open up. I'm going to do a really bad little sketch just to remind myself it's going this way. Okay. The next thing I need is my focus, which is P units inside my parabola. So it's 3 units inside of here, which is at 3, 1, 3, negative 1. The axis of symmetry is just the line that cuts this in half. Can anybody give me an equation of that? Everybody good? X equals right through both the vertex and the focus, which I should have labeled as 4 or 3, negative 4, sorry. All right, then the directrix is how many units away from my parabola? 3 again, 3 down this way. So if I go 3 further down here, I'd have y equals negative 7. All right, I have everything they asked for, but I want to go one more time through this same problem by having you look at your sheet. What does it say on your sheet when you have this kind of parabola? Okay, it's opening up or down. I need you to read me focus and directrix. Can you tell me what those two things say? It says for focus, what? H comma K plus P. Did I hear you right? And the directrix? Y equals K minus P. Okay. If you had that right in front of you on your sheet, could you have just put in these numbers? 3, and then added those together and you get negative 1. There's your focus. Y equals negative 4 minus 3 is negative 7. Okay? Am I tying together the recipe and the concepts for you? All right, let's try one together. Let's try this one. Now, something different right away. The y is the squared quantity. So when you go to your sheet, which kind of parabola are we looking at? One that's opening either left or right, okay? So I'm going to write under here y minus k, quantity squared, equals 4px, if I could write, minus h. All right. Then, before I do anything else, I want to think about which way this is going to open, because that's going to make a difference when we look at the sheet. Yeah, maybe we should just find those values real quick. H is what? Negative 3, negative h, so h is 3. Positive 1, negative k, so k is negative 1. And p, if 4p equals 8, p is 2. All right. I really do like to graph these as I go. This is nice graph paper. I go over 3, down 1, and there's my vertex. Okay. It's a positive p, and it's a y squared, so it's opening to the right. Okay. So 2 units inside there, or 2 units to the right, is my focus. Now, I think I can get it just off the graph paper, but just to tie it together again, can someone tell me what it says on your sheet for a focus? So that would be 3 plus 2 comma negative 1. Does that look like we wound up at 5 negative 1? Okay, right there is 5 negative 1. Seems okay. Now, if it's opening this way to the right, then I'm going to also need a directrix that's 2 units back to the left. So I'm thinking here, what does it say on your sheet for directrix? Okay, so that would be x equals 3 minus 2 or x equals 1. Does that seem like where I drew that line? All right. I always forget the axis of symmetry. Let's do that real quick. The axis goes right down the middle through the focus and the vertex, which have in common what, guys? The y of negative 1. Okay, that's the axis of symmetry. Yeah, symmetry axis. I'm writing that upside down because that's what, yes. Yes. When you go to actually draw the parabola, it's kind of hard to know how wide it is, okay? I will tell you, the bigger the p-value, the wider the parabola. The smaller the p-value, the narrower the parabola. All right, I'm only going to require that you find 1 point, and it can be a decimal. It doesn't have to be anything pretty. I just want you to get 1 point so that you're close to how wide it should be, all right? This is a little bit of a struggle because you can put either an x or a y value in, but you have to think about where you're going here. If it's going off this way, can I pick a negative or a 0? I guess I could pick a 0 to find the x-intercept, but that's not very far away. Okay, do you want to put an x or a y in? Put an x? Okay, so we're going to need something out here, right? I don't think it's going to matter. So pick an x value that's out here. 1, 2, 3, 4. Okay, it's not too far out, but let's put a 4 in for x. So I'm going to pick x equals 4 to start. Now, I'm going to put it in my original equation. It'll say y plus 1 squared equals 8 times 4 minus 3. So on the right-hand side, all I have is 8, right? Because 4 minus 3 is 1. Everybody okay? How do I get rid of this squared thing? Square root. And I really could do plus or minus because it would go up or down, but I'm not going to worry about it. Y plus 1 equals the square root of 8, and then I'm going to subtract 1. So I don't care. Type it in your calculator. What crazy decimal do you get? 1 point something? Square root of 8 minus 1 is 1.8. So if I go 4 over, I go about 1.8 here. And it's actually symmetric. So if you counted back to the y-axis, you would go the same amount down this way. Because that's the whole point for the line of symmetry, right? The axis of symmetry. That's the hardest part, and I'm not going to be super picky about accuracy on width. I would like you to practice finding 1 point. But I know it's a lot of work. Yes. The axis of symmetry, not the x-axis. So 1, 2.5, 1, 2.5. Yes. Okay, go ahead. We good? Okay. All right. Can you try talking your way through this? I will tell you right now what's going to happen when you go to do P. It's just going to be P is 1, so that's not too bad. The graph paper stinks, yeah. I promise not to give you graph paper that counts by 2 on a test or quiz, okay? So work on this, talk to whoever's sitting next to you. It really does help. Whole book written called Algebra Out Loud about how important it is to talk to yourself or talk through things. I know some of us do it in our head, but find the pink sheet. All right, who can start me out? What'd you get for H? -2 for K. +1, and for P, 1. So it opens which way? Up. So the vertex is -2, 1, which is here, I think, if we do the graph paper correctly. Everybody okay? The focus is 1 unit above that, or -2, 1 + 1, right? Did someone have the focus at -2 too? All right. The axis of symmetry cuts right through what? X equals -2. Everybody all right? It's a vertical line that goes right through both of those points. Okay, the directrix, on the other hand, is a horizontal line 1 unit below this, so it's actually at what? Yep. It would be y equals k minus p, which is y equals 0. All right. Now, you want to put in an x or a y? You want to try a y this time? Okay, so let's pick a y value. It's got to be up here somewhere, right? Because it's going to go this way. You want to put in y equals 8? Okay, I don't know how wide that'll be, but let's put in y equals 8. X plus 2 comma squared equals 4 times 8 minus 1. And remember, we put in an 8. Sometimes I forget what I put in. That would be 7 times 4 is 28. Square root 28 and subtract 2. Sounds like about 3 to me. Square root of 28 minus 2, 3.3. So if we went over to 3.3, we'd be up here at 8. Now, that's like 1, 2, and almost 3 boxes. I'm just figuring symmetry. Yes? Go on either side there. Now, be careful when you draw your parabola. Which dot is it supposed to go through down here? The vertex, right? Not the focus, the vertex. Oh my goodness, I totally missed the dot. Yeah, big dot theorem, exactly. That wasn't too bad. All right. What changes on 3? Yeah, 4p is going to be 2 equals 4p, so p is 1/2. Okay, can we kind of talk through this one together quickly? Yep, This is y minus k, x minus h. So h is 6, k is 3, and p is 1/2 or 0.5. You can use a decimal. Vertex, Jared. Vertex is always hk. Now we need, before we go any further, we need to decide which way this is going to open, right? It's y squared, so it's sideways. And p was positive, so it's going to open to the right. So the focus is going to be inside of the parabola that goes this way. By how much is it inside? 1/2. So it should be just inside here. But go ahead and tell me what it says on your sheet. When it opens to the right, the focus is at h plus p comma k, which is 6.53. Does that seem all right? That was a half unit inside there. Can I skip drawing the axis of symmetry at least? Because it's going to mess up my picture. Can you find me the axis of symmetry? What line goes through there? Y equals 3. It's, guys, it should be what they have in common, right? They have in common a y value of 3, because the line is going to go through both of those. All right. That was the axis of symmetry. What am I missing? The directrix is x equals h minus p, is that right? Which would be 6 minus 0.5. So x equals 5.5, which is this line right here, if I were pretending to draw it accurately. All right. Is everybody okay so far? Then the icky part is trying to find a point. Let's pick an x like 10. So we're looking on this line somewhere to figure out how wide it should go. There's the line x equals 10. So I'm going to write 10, comma, and put a 10 in up here. Ten minus 6 is 4, times 2 is 8. Square root of 8 plus 3. 5.8. Yes, Camden. You can pick a y. You would just need, yeah, you could pick any y. Because this is going to go, the domain, the range is all real numbers. Yes. What did I get? 10. 5.8 would be almost 6, right? Here's my axis of symmetry. I don't know. I'm going to fake it. Is it kind of narrow? Yeah. Okay. Compared to the last ones, it's really narrow, as p was less than 1. All right. I'm thinking I may not do the whole next problem, but just help me rearrange it, because it's a mess. Anybody looking at it, seeing what I'm talking about? On my sheet, it says x minus h squared equals 4p y minus k, doesn't it? This is in the wrong spot. Now, we had a real struggle with this one period today. How do you get a fraction from one side to the other side of the... If it says 1/2 x equals y, how do I get x by itself? Multiply by 2 over 1, right? And then it becomes x equals 2y. So to multiply here, I'm going to multiply by negative 12 over 1. So it would become x minus 3 equals negative 12 y minus 6. Say that again? Well, they were just like, where in the world did you get that negative 12? So, here's the issue, guys. Just help me think about which way this is going to open. X is the squared value, so it opens either up or down, and it's negative. P would be negative 3, so it would open down, okay? The vertex would be at 3, 6, and 3 units inside of here, and 3 units back this way. There's a rough sketch. Is that good enough? Can we be okay and not do all the pieces for this one? Are you feeling pretty comfortable about using the recipes? All right, I hope so, because now we're going to go backwards. Okay. Given, all you're going to be given is the focus and the vertex. Well, with your little recipe, you can find everything from the focus and the vertex. Now, I'm going to tell you how I would do this question, and then I'll show you how to just use the recipes, okay? If I were doing this question, I always sketch. I would go, okay, my vertex is at 1, negative 3. My focus is at negative 4, negative 3. Oh, so it's opening this way. And actually, this is a pretty far distance, so I know it's pretty wide. Okay. The opening sideways helps me know which formula. I got to figure that out so I can look on here. Okay, so the sketching the graph helps me. Vertex is H, K. So what do you know right away? H is 1 and K is negative 3. Everybody okay with that? All right. Now, if you looked on here, you would notice, even if you didn't graph it, which parabola has the same K on the focus? The one that opens up and down or sideways? Sideways, right? K stays the same. And for that focus on that sideways one, the recipe is H plus P comma K. Well, you just told me this is 1 and this is negative 3. So what did they do to get a focus at negative 4, negative 3? They did something here. How did 1 plus P become negative 4? P is negative 5. I'd rather look at the picture. If this is to the left 4 and down 3, and this one was to the right 1 and down 3, how far apart are they? 5 units, right? But it opened to the left, so P is negative 5. Does that kind of make sense when I explain it that way, so we could find the P? Otherwise, you can follow the recipe. All right, once you have those, all it is writing it in. You said it's sideways, so the general form for sideways is here. Can you plug those numbers in? Y minus, y minus negative 3 or plus 3 squared equals, 4 times negative 5 or negative 20, x minus h or 1. All right, can we do one more quick one, and then I'm going to talk about quiz questions, okay? Because I know some of you were unhappy with that quiz. Yep. Let's try 7. Let's try 7. Vertex of 5, 3. So what do I know right away? H is 5, K is 3. It always helps me to sketch, so I'm going to go ahead and sketch. 5, 3 would be somewhere over here. It says it opens down, right? Okay. Which I maybe could have figured out anyway, because if I knew that y equals 6 is the directrix, would that have told me it had to be opening away from that, right? Okay. Now, actually, conceptually, can anybody figure out what P has to be? Because it's this distance, right? This was over 5 and up 3, and this is at y equals 6. So the distance is 3. Okay, pretend I didn't know that. Look at your recipe sheet. Can you find which parabola has a directrix of y equals anything? One that opens up or down, right? And it says y equals k minus p. So if I know y equals 6, and I know k is 3, I can put that in here. 6 equals 3 minus p, and solve, and you get what? P is actually not 3, it's what? Negative 3, because it's opening down. Yep. Okay, one more time. Let me go back here. I lost some of you there. When I look at my sheet, it says y equals k minus p. Well, I know right here that this is a 6, and I know right here that this is a 3. If I subtract 3 from both sides, I get 3 equals negative p, so p is negative 3. Is that a little better? Okay. Now write the equation. Well, I look on the sheet and it says x minus h quantity squared equals 4p times y minus k. So that would be x minus 5 squared equals what? 4p would be negative 12 times y minus 3. Not so bad? Okay. I'm going to stop recording and